Students, welcome back to my YouTube channel Mathematical Lens by Namita. In this video, we are going to continue with chapter number 3, number play of grade 6 mathematics, that is the new NCERT textbook Ganitha Prakash. So in this video, we are going to talk about the clock and the calendar numbers. Okay, so here let us see. On the usual 12-hour clock, there are timings with different patterns, like 4:44 or 10:10, 12:21, right? So try and find out all possible times on a 12-hour clock of these times. So first we need to try, so like 4:44 is already given. So it can be like, let's see, it is 1:1. That is 1:11, or maybe it is 2:22, right? And 3:33. These are different possibilities. You can write more. Okay, 4:44 is already given, 5:55. Fine. Now, Manish has his birthday on 2012, where the digits you can see 2012 repeat in that order. 2012, 2012. Right. So they have asked us find some other dates of this form from the past. Now, if you want to find such dates, you have to choose a particular year which can be repeated. Okay. So, means whose dates, and it should fall in that month. There are 12 months, right? So, and the date we can write only till 30. So, that you need to keep in mind and write. Like, suppose if we take the year 2008, then 28 date is possible, right? So, that you need to keep in mind. So, 28, 2008. This is one possibility. Like suppose if you take the year way back, if we go in the past, then 1912 if I take. So 19 date is possible, 12th month is possible, right? So you choose a proper year whose repetition as a date and a month is possible. So 1912, 1912. Okay, I have written two possibilities. You can write more on your own. Now his sister Meghna has her birthday on 11/02/2011, where the digits read the same from left to right and from right to left. Now see the difference here in both the patterns. Manish birthday, here the 4 digits were just repeating. 2012, 2012. Here what is happening is, if you read from right to left and left to right, the numbers are same. You can see Meghna's birthday 1102 2011. So if you read from here 1102 2011, right? So the palindromic numbers which we learned in the previous video, okay, in the same chapter. So now you have to choose dates whose palindrome is a possible, like you read from left to right or right to left is possible, right? So if let us try some numbers. Suppose we take the year 2001. So if first we choose the year, okay, as I told you. So what will be the reverse of 01? It will be 10. And 20, the reverse will be 0, 2. Now if I read this 1002 2001. So if I read it from the right side, 1002 2001. This is a palindromic number. Right now, if we try some other number, like if we take 20,002. So what will the reverse of 02? It will be 20. So we take the date as 20 and we take the month as the second month, February. So 2002, 2002, 2002, 2002. Whether you read from right or left, it is the same. We'll try one more. Let us take the year 2010. Right? You see the pattern how I am choosing the years, right? Whose date is possible, the reverse is possible. So this is 10. So we write the date as 01, that is the first of month. And the next number is 20, so 02. That is 1st February. So 0102 2010. So 0102 2010. This can be read together. Okay, from left to right, right to left, it reads the same. So this is a palindromic date. So you should understand the difference between Manish's birthday and Meghna's birthday. They both are different. Here also there is a pattern. 2008, 2008. The four digits are repeated. But here you can read it from right to left and left to right. Both will be same, which are palindromic dates. Now Jeevan was looking at this calendar. He was wondering, why should we change the calendar every year? Can we not reuse a calendar? What do you think? You might have noticed that the last year's calendar was different from this year's. Also, next year calendar will also be different from the previous. So why does this happen? Like if we see any calendar, maybe like the first day of the month, like 1st Jan, if it starts from Monday. So it is not necessary that 31st December is a Sunday, then it again starts from Monday because it is 365 days, right? So it is not necessary that we have the same calendar every year. But after few years, you may have the same calendar. But after how many years, we need to find out that. So there is a pattern like for the common years. So if we take this year as a common year, like 2025, if I talk about 2025, it will be repeated. It is this year's first day is on Wednesday, right? This will be repeated after 6 years. So you can say it will be repeated in 2031. Right? So common years are generally repeated after 6 years or 11 years, right? It depends on the leap years which are coming in between. So I'll write here for common years, repeats after 6 or 11 years. So like I gave you the example of this year, 2025 will be repeated after 6 years, that is in 2031. You can check that. Now, if we talk about the leap year, you know what is a leap year? Leap year, like last year was a leap year, 2024. It should be divisible by 4. That's a leap year. So, leap years are repeated after 28 years. So, 2024, if we talk about that, if we add 28 to 8, we get 25.2. So this 2024 will be repeated in the year 2052. Now let us try to solve this figure it out exercise which is given on page number 64. So there is a question given over here. Pratibha uses the digits 4732 and makes the smallest and the largest 4-digit number. So the smallest digit is, you can see it is 2347 and largest is 7432. The difference between these two numbers is 5085. And if we add these digits, you get 9779. Now they have asked us to choose a 4-digit number so that the difference between the largest and the smallest number, it should be greater than 5085, not less than 5085. Right? So what you can do here, they had taken digit as 7. We can take the digits as like 9. If you take a greater digits, there are more chances of the possibility. So if we take this digits, 9, then 3, then we take 1 and 6, right? So if we choose this 4 digits, so the largest number will be 9631, and the smallest number will be 1369. So if we choose digits like this, here the largest is 9 and the smallest is 1. So you will get a sure short answer. Otherwise you will have to choose, maybe you have to do trial and error, right? Because 9 minus 1 is 8. So it will be more than 5000. So here the difference is 8262, right? Which is larger than 5085. That's our first answer. And it's your choice. You can take other digits as well. I have given you one example. Now, B is the difference between the largest and the smallest number should be less than 5085. Now we choose a number, we wanted a number which is greater than 5085. Now we want a number which is less than 5085. So now we choose the digits wisely. You can even take the largest digit as 5, because when you subtract 1, it will be 4000 something, so it will be less than 5085. So we choose the number like 5, 3, 1 and 2. So the largest number formed will be 5, 3, 2, 1. Smallest will be 1, 2, 3, 5. And if we find out, the difference between both will be 4086, right? Which is less than 5085. Again, here you, instead of 5, you can choose 4. But you should not choose a number, the largest number more than 6 or 7. Otherwise, you may not get the difference as 5085. Otherwise, there are many possible answers. Okay. Now let us see the third question, which is, now the question C says that the sum of the largest and the smallest number, it should be greater than 9779. Okay. So now here it is compulsory that you take the greatest digit as 9. If you take any other digit, then again there are chances of getting the answer will be less. So we choose the number, the digits as 9, 1, 2, 3. The larger the number you take, the larger the chances increases. The largest number is 9, 3, 2, 1 plus 1, 2, 3, 9. So you can see that 9000, this is around, if you take the round figures, 9000 plus 1000, it will be more than 10,000. So naturally it will be more than 9779, right? So if you choose 9 as the greatest digit, you will surely get the answer greater than 9779. So the answer is 10,560, which is greater than 9779. Now in D, they have asked sum of the largest and the smallest number, it should be less than 9779. Now here, we don't choose the largest digit as 9. We take it as suppose 7. And the other digits may be 5, 1, 2. So if we take the largest digit as largest number as 7521 plus 1257. So here if you just see the round numbers, 7000 plus 1000 will be 8000, and this will not be even 1000, the other digits. So it has to be less than 9779. So you can first guess like that and then actually add it. So the sum is 8778, right? So it is less than 9779. Okay, I hope you are getting how to go about such questions. Now they have asked question number 2, what is the sum of the smallest and the largest 5-digit palindrome? What is their difference? So they have asked the sum and the difference of the smallest and the largest 5-digit palindrome. So first we see the smallest 5-digit palindrome, which is the smallest 5-digit palindrome. So which is, first we think of the smallest 5-digit number. Okay. So which is the smallest 5-digit number? It is 10,000, but it is not a palindrome. Now if we take the next number, It is 10,001. Right? So 10,001, if you see, it is a palindrome 10001 and 10001. So that's a palindrome. Now we see the largest number. Now which is the largest number? 99,999. So it is of course a palindrome because all digits are same. You read from right to left, left to right, it is same. So if we add, what will be the sum of these two numbers? The sum of these two numbers will be 1,10,000. Okay. You can add it easily. If you add this is 1,99,999 plus 1 is 1 lakh and 10,000 extra. So 1,10,000 is the sum. Now what is the difference? Difference also you can find out mentally, right? So it would be 89,998. Okay. So you just subtract 1 from here, 1 from here. So you get the difference between the largest and smallest 5-digit palindrome. Question number 3. The time now is 10:01, means 1 minute after 10 o'clock. So 1 minute past 10 o'clock. So how many minutes until the clock shows the next palindromic time? And what about the one after that? Okay. So if we see, like, first we write down the next palindromic number. So first this is given as 10:01. So next would be 11:11. Okay. That's the next palindromic number. And if we see the next after 12, it would be 12:21. So these are the palindromic numbers in sequence. So if we find out the difference between these two, it is 70 minutes. You can see it is 1 hour and 10 minutes. So 70 minutes. Now if we see the difference between 11:11 and 12:21, that's also 70 minutes, right? So you can conclude that the next palindromic number will be after every 70 minutes. That is after 1 hour, and then just calculate the next 10 minutes. Question number 4. How many rounds does the number 5683 take to reach the Kaprekar constant? You remember the Kaprekar constant, what was the number? 6174. If you remember the steps. So let us do the steps and find out how many rounds will it take. So if we start with 5683, what will be the largest number? Like if we do step 1. So with these digits, the largest number will be 8653. And if we subtract, it is the smallest number, so 3568. So if we find out the difference, it is 5085. We are not getting 6174. Now let us try the second step. So second step is, now we form the largest of 5085. So it is 8550 minus 0558. The difference is 7992. This is the second step, but still we are not getting 6174. Let us try the third step. The largest number will be 9972 minus 2799. If we find out the difference, it is 7173. This is the third step. So let us try the next step. 7731 minus 1377. Right? So here the difference is 6354. Still we have not reached the number 6174. Okay, now let us try the fifth step. It is said that you get the answer in 7 steps, maximum 7 steps. So let us see what happens here. So now if you form the largest number from this, it is 6543 minus 3456. Okay, so the difference will be 3087. Still we have not got. Now the sixth step, 8730 minus 0378. So here the difference is 8352. Seventh step, 8532 minus 2358. Now if you find out the difference of this, you will get 6174. So after 7 steps, you got the Capricorn's constant, right? So maximum 7 steps it takes. Otherwise, sometimes in some numbers you reach in 1 or 2 steps also, right? So keep trying with different numbers and get the Capricorn constant. It is fun, and even your mental maths will improve with that. Okay. So we'll continue with this chapter in the next video. Thank you.